In this lecture, we are going to see about bubble sort. Generally, sorting is nothing but arranging an elements of an array or a list in an ascending order or descending order. Generally, by default, the sorting order is ascending. In this bubble sort, we are going to compare two adjacent elements, and after comparison, if they are not in a particular order, then we will swap this. So when this process has to be continuously done, and while it is being done, the largest element from the array is being bubbled up to the end of an array into its proper current position after every pass. So hence the name bubble sort. We will see an example for this bubble sort. Let's take an example of an array A having elements 5, n is equal to 5. So our array index starts with 0, 1, 2, 3 and 4, that is 0 to n minus 1. The elements of an array are 15, 16, 6, 8 and 5. So our basic funda is we need to compare the two adjacent elements, and if it is greater we need to swap. If not, we will retain as such. The other elements will be retained as such. So we will check first 15 is greater than 16 or not. If it is not, we will not swap. So 15 is not greater than 16, so we will keep that element as such. Next we compare 16 and 6. So we will check whether 16 is greater than 6. Yes, 6 is smaller, so we will swap these two elements. So the rest of the elements remains as such. So next we will compare 16 with 8. So when we compare 16 and 8, 8 is smaller than 16, so we will swap 16 and 8. So after swapping, this is the elements of an array. So next 16 and 5 is compared, and since 5 is less than 16, it is swapped. So these are the 5 different comparisons that we have done in single pass. So in one pass, we have 5 comparisons being done. We move on to the next pass. So now the array elements will be 15, 6, 8 and 5. So we compare 15 and 6. If it is less, we swap. Then we will compare 15 and 8. It is less, so we will swap this. Next we have 5 and 15. So we will 5 is less than 15, so we will swap this. Next we have 15 and 16. So we will again check with this. So at last we have two elements in the last position. So in our first pass, we have seen that 16, the largest element of an array, gets bubbled up towards its last position. Similarly, in our second pass, like two elements have been into its proper position. So every pass we have the largest element will be bubbled up towards the last position. Now we will have the elements after the second pass is 6, 8 and 5, 15 and 16. We will move for the next pass. So we compare these two elements. It's in the order, so we will not compare, swap. So then we will compare 8 and 5. It is less, so 5 is being swapped with 8. Then we have comparison between 8 and 15. It is not necessary to swap, so we will retain it as such. Next we will have the comparison between 15 and 16, and we have after the third pass 3 elements getting in its own current position in a sorted way. So now these are the elements that we will be taking into the next pass. So we have 6, 5, 8 and 15 and 16. So we will compare these two elements, and since 5 is less than 6, we will swap 6 and 5. So 5 and 6 get swapped. So next we compare 6 and 8. It is need not to be swapped as it is in an order. Next we compare 8 and 15. It need not be swapped. Next we compare 15 and 16. It need not be swapped. And at last, after the fourth pass, we have all the 4 elements at its proper position, and fifth element, that is 5, that being the first in position, it need not be compared with any other element as there is only one element in the array, hence it need not be swapped. Now we can find out all the elements are being in its own position in a sorted order. So totally we have come across with 4 passes. So for in general, if there are n elements, we require n minus 1 pass. This may not be the case for all. but in general this is the case. Now we will see about how to implement this particular bubble sort. So we generally need two different loops. Okay, one is for different passes, the variable I for considering different passes, and we need one more variable j for a comparison of elements between the adjacent elements. So if that is there, we need to go for swapping. So as we have discussed, we have two loops. One is for the total number of passes that we need, so it requires n minus 1 pass, so I varies from 0 to n minus 1. Then the next pass is for comparing the elements inside the pass. Okay, so we have j less than n minus 1. So we need to compare the adjacent elements. If it is greater, then what we do is we go for general swapping of the process. So this process or this algorithm can be optimized in order to compare the elements with less number of passes. For example, let us the example that we have seen, we will see an criteria wherein we need not require many more comparisons. For example, in our fourth pass that we have, we need not go for this comparison as it is already in a sorted position. Similarly, we don't require this comparison as it has been already sorted. Similarly, we don't require this comparison as because like we have already the elements in a particular sorted position and we don't need such comparisons. Similarly, when we consider this pass 3, so it is already in a sorted position, we don't need to compare. This is again we don't need to compare. So the total number of comparison that we make here need not be taken into consideration. So how are we going to optimize the algorithm that we have written over here? So we will optimize this by reducing the less number of comparisons by decrementing as I increases. As we see the I value increases, the number of pass or the comparison decreases. So here we don't need so much of comparisons as the arrays are being elements in the arrays are being already at its particular position and we need not sort it. Similarly, we can also optimize like suppose after this third pass there are some cases wherein after a particular set of passes we need not compare the elements as it is been already in a sorted position. It need not require n minus 1 pass. So in that case, how are we going to check is we will check whether a pass has a swapping or not. If there is a swapping, then we will go for the next pass. If there are no swapping in the particular pass, we will not go for the next pass itself. So we will use one more variable called flag variable, and if any swap is happening in our pass, we will increment that flag variable. So if there is no swapping in that particular pass, we will not increment the flag, and in case we will come out of the pass, there is no need for going into another pass. We will now write the coding for that. As discussed, I have modified this particular coding wherein we have set up a flag variable to identify whether there is any swapping in the pass process. Okay, so then I said like to reduce the number of comparisons, so I have made the change over here as n minus 1 minus I, and if there is any swapping occurs, we initialize this flag or we increment the value of flag by 1. If it means if there is any swapping, we will go for the pass. If not, if the flag value is remaining at 0, then we will break and come out of this loop wherein we will stop our pass iterations. So we will now see how tracing or how it works by looking into our example. So let's check our code that we have written. We are taking pass 3, that is I is equal to 2. Suppose when I take I is equal to 2, how the number of comparisons is getting reduced. So when I have I is equal to 2, my condition is I will check whether j. Okay, so I is less than n minus 1. It is 5 minus 1. Yes, it is true. So now it gets into the j loop. J is equal to 0 and it checks j less than 5 minus 1 minus 2. That is n minus 1 minus I. Yes, 0 is less than 2. Hence, it enters into the if loop if a of j, that is 0, is greater than a of j plus 1, that is a of 1. So the value of a of 0 is 6 and a of 1 is 8. Is it greater? No. So we will not go for swapping of the process. Now j gets incremented by 1. It will check 1 less than 2. Yes. In that case, a of j greater than a of j plus 1. It checks this condition. A of 1 greater than a of 2. So 8 is greater than 5. Yes. So then it goes for swapping. So we did our swapping process here. We swapped this 5 and 8. So next, j gets incremented by 2. So it checks whether 2 is less than 2. Is 2 less than 2? No. So if, and here it is not less, so there is no need, it comes out of this for loop and no need for this set of comparison, these two sets of comparison. So we are not entering into the comparison of values, which is not at all required, because as it has been already sorted. A similar way, we can have another example or some other example wherein we don't require n-1 number of passes, and for that this particular code works, and you can take an example and kindly check it off. Thank you.